just imagine that there was an underlying graph on it, but before the graph is generated.
You may notice I've changed the title of my talk. So initially I was planning on giving kind of a normal research talk focusing on some specific problems. But then when I sat down to write the talk, I thought, what the heck? I'm going to try to organize this around what I think is a sort of fundamental problem in this area. And all of the other problems that we see are sort of, would be much easier to solve if we could address this fundamental problem. I don't get a chance to talk to you all that often, so might as well give it a try. So this is joint work with a graduate student at Princeton named Dennis Feehan, and a lot of this work will be part of his dissertation, so that if there are any ideas in this talk that you like, they probably came from Dennis. And then I'm also going to talk some about a specific empirical project we did in Rwanda, and these are the collaborators on the project in Rwanda. So for about 10 years now, I've been working on problems sort of at the intersection of networks and statistics, motivated by this empirical problem. That is, there are about 30 to 35 million people in the world who have HIV. And in most countries, this disease is concentrated among the people most at risk for the disease are in these three risk groups: drug injectors, sex workers, and men who have sex with men. And so we'd like to know more about these groups so that we can understand how the disease spreads and so that we can effectively design interventions. So sort of catchphrase for this in public health is know your epidemic. So now to make this a little more concrete, imagine if you're the director of UNAIDS, the UN HIV/AIDS organization, and your goal is to stop the spread of HIV in the world. It would be very difficult if you didn't have reliable information about the groups most at risk for the disease. And that's kind of the situation that we're in now. It's sort of like you're flying blind because it's so difficult to collect this information. And the reason is that these groups are very hard to study using standard sampling methods. So the kinds of questions that we ask about these groups, they're actually really easy to state. So typical questions are like this. What percentage of drug injectors in San Francisco have HIV? A second question that comes up frequently is how many drug injectors are there in San Francisco? So these are questions about the prevalence of some trait within the hard-to-reach group and then the size of the hard-to-reach group. And so I've worked on methods like respondent-driven sampling and the network Scallop method, which are both network-based methods for trying to answer questions like these. One aspect of these I think is different than a lot of the other things we'll hear about today. In these settings, we're most interested in characteristics of the nodes, and the edges are just ways of accessing those nodes. So a lot of the talks we've heard so far have been interested in network structure itself. These were really just interested in the nodes. The network structure is just a vehicle to access them. However, it turns out that properties of the network structure affect our abilities to answer these questions. So as I said, I've been working on this for a while, and I think it's often not completely satisfying because of this problem. Is how can we actually improve if we don't know how we're doing? So this is a little bit metaphysical, but I've tried to keep it intentionally vague for a second because I imagine that many of you have addressed problems like this in your own field. And so I'm very curious to hear how people try to solve this problem. In terms of the area where I work in with these hidden populations, I will sort of turn myself into a straw man for a second to give a concrete example of this. So this is from a study that I did with a number of Brazilian epidemiologists to estimate the number of heavy drug users in Curitiba, Brazil. It's a city of about 2 million people in southern Brazil. So here, the x-axis is the estimated proportion of the population that is a heavy drug user, and these are 5 different estimation methods. For now, we can just forget about what these mean. So basically, we produced 5 different estimates that differ by a factor of 10. So then the natural question that the people in Brazil ask is, okay, great, which of these is right? And the honest answer is we don't know. All we know is that they are different. One side note, we heard some stuff about data availability earlier. I want to say that in all of our work, we try really hard to make the data publicly available given the legal and ethical constraints. So in this, for example, for this particular paper, all the data is publicly available in the Office of Population Research Data Archive. Okay, so now I'm going to try to tighten up my question a little bit, make it a little bit less metaphysical. So how can we reliably make progress in our ability to estimate quantities that will never be known? And by never be known, I don't mean that we can't define these things. So we can define what it means to be a drug injector. We can define what it means to live in San Francisco. So it's a well-posed problem. It's not a problem stating what we're trying to do. But it's hard for me to imagine a situation where financially and ethically we'll be able to make this sort of gold standard measure. So how is it that we can move beyond just saying, well, these are all different? In practice, what happens usually, so in this case, all of these were produced by one research group, so we don't fight within ourselves very much. But I've been to a lot of meetings where someone does it one way, someone does it the other way, and then they kind of argue. And whoever can yell the loudest, that's the estimate that ends up being used. And that is really not what we want. We'd like to have some way that we can actually reliably make progress and distinguish between different people's claims. So I think there's sort of two main ways that we could try to do that. One way is theoretically, and one way is empirically. So theoretically, I mean, we could have statements like, if X, Y, and Z are true, then method 1 is better than method 2. I'm actually not very optimistic about this, which I probably should not say in a room full of theorists. Let me tell you why. In this particular setting, it's very difficult to make statements like that. Because even to make a clear statement like, if X, Y, and Z are true, you often have to assume other things, A, B, and C, which are definitely not true. So that statement is of limited value. Another reason that statement is of limited value is because it's often hard to know if X, Y, and Z are true. Because when these populations are hidden, we really do not know that much about them. It's very hard to reliably measure any of these things. So I'm not very optimistic about this theoretical approach. So I wanted to try to come up with some empirical way that we can make progress that would not require a lot of untestable or unrealistic assumptions. And so that's what we've tried to do. So let me talk a little bit about the setting in which we do this. So we've come up with a way to try to do this within something called the network Scallop method. So now I'm going to tell you a little bit about the network Scallop method and how it works. And then I'll tell you about how we can try to reliably make progress within the framework of this method. So the original insight behind this method was developed by an anthropologist named Russ Bernard, who was in Mexico City in 1985 during the terrible earthquake that happened there. So at the time of the earthquake, there were widely different measures of the number of people who had been killed. And it was particularly politically contentious because the government had been putting out lower estimates and other people had been putting out higher estimates, so no one really knew what was going on. And Russ said, well, everyone that I talk to seems to know someone who's died in the earthquake, so it can't be true that there's only a very small number of fatalities. So the insight that there's somehow information within the personal networks of the survivors about the number of people who have passed away. And so then Russ and some of his colleagues have worked for a long time trying to turn that intuition into a statistical method. So here's how it works. So here's a population of 30 people, let's say 6 of whom have red hair. We'd like to estimate how many people have red hair. So we can take a sample of one of those people. We can see that this person is connected to 10 other people, 2 of whom have red hair. So that our estimate for the size of the target population, that is the number of people with red hair, is just the prevalence within the personal network of the respondent times the total number of people in the population, which in this case gives us an estimate of 6, which is exactly right. So this method is awesome. So obviously you would not want to do this with just one person. So if you take a larger sample, this is the estimator that you get. And the rough intuition for this is you can think of it as sort of a generalized sample proportion. So in a normal sample proportion, you take the number of people who say yes divided by the number of people that you talk to. Here you take the number of people that are connected to the respondents who have that trait, so the number of drug injectors connected to your respondents, divided by the estimated number of people who are connected to your respondents. And then again, you take that proportion, you project it over the whole population. So that's the intuition for the method. Yeah?
So if you had some high degree nodes which had red hair, then you would be biasing towards that, right? You'd get an estimate that is higher.
That is absolutely right. So that is one of the many problems with this estimator. So one of the things we did, which I don't want to talk about exactly here, is we've come up with ways of trying to estimate the average degree of people in the target population, which would allow us to undo this problem. OK, so how does this work in practice? How does the data collection actually happen? So it requires a random sample from the entire population. It does not require a sample from the hard-to-reach group, which is a big advantage, unless you want to estimate some of these correction factors, in which case you do need a sample from the hard-to-reach population, and that would be a separate talk. So the respondents are asked questions like, how many people do you know who are drug injectors? These are the target populations. And then they're asked about a bunch of populations where we know the answer. So how many women do you know they've given birth in the last 12 months? How many people do you know who are middle school teachers? How many people do you know named Michael? These are all groups where we know the sizes of these groups from administrative records. So roughly what's happening is these questions are going into estimating the respondent's degree. So that's the denominator. And then this is the numerator. And then one question in terms of the operationalization is also, how do we define what it means to know someone else? So here, the way it's typically defined is you know them and they know you, and you've been in contact with them in the last 2 years. So it's a particularly weak notion of a tie. I guess everyone here is familiar with the idea of weaker and stronger ties. So this struck us as kind of an interesting thing because it's something that every previous study has used basically this definition. And it's extremely weak definition of a tie. So we thought maybe that's actually not the optimal definition of tie strength. Maybe we could get better estimates if we tune this parameter some. And so we asked Russ, like, how did you guys come up with this definition? And he said, oh, we just thought it seemed reasonable for the first time. It's like, OK, that makes sense. And then everyone else has pretty much kept doing it. But in fact, this is actually something that we, the researchers, can choose and tune to try to get better estimates. So let me sketch out a cartoon model of why I think this might not be the best definition. I should put model in quotes in this audience, I guess. So you could imagine an array of tie strengths from very strong to very weak. And as the tie definition gets weaker and weaker, you can sort of imagine we're collecting more and more information from each respondent. So you would imagine that your sampling error would go down. But you also might imagine that your non-sampling error would go up. That is, people don't have perfect information about their weaker ties. So you might imagine as the ties get weaker and weaker, the non-sampling error would go up and up. And so then if you put these together, you get something that looks like this, where you think your error is a function of the tie strength. And then when you see a picture like this, you naturally would like to know what that point is. So we set out to try to find that. So we did this in a survey experiment in Rwanda. So this was a study funded by the UN and USAID to estimate the sizes of the groups most at risk for HIV in Rwanda. So these are drug injectors, female sex workers, clients of female sex workers, and men who have sex with men. And we had a nationally representative sample of 5,000 Rwandans face-to-face interview. This sample was selected using standard probability methods. So now what we did is we had a survey experiment where half of the people got one definition of what it means to be connected to someone else, and half got a different. So half of the respondents got this basic definition, which is modeled after the definition that had been used a lot in the past. Someone that you know by sight and by name, and that also knows you by sight and by name. So this is to produce reciprocity. It's people that you've had some contact with in the past 12 months, and people of all ages who live in Rwanda. So then the other half of the respondents got this meal definition, which is also people you know by sight and by name, but people who you have shared a meal or a drink with in the past 12 months, and again, people of all ages who live in Rwanda. So these two this stronger definition is completely nested within the weaker definition. Okay. So, and we also, so before I say sort of what happens, I want to say that we really did not know what was going to happen exactly. So no one had done a study like this in sub-Saharan Africa using the Scallop method. And also, if you think about it for a second, these questions are actually quite difficult to answer. So I'm going to just ask you all, how many women have you shared a meal or a drink with in the past 12 months that have given birth in the past 12 months? Just think about it for a second. Okay, so it's hard for you, people with PhDs who think about networks, to answer these questions. And one thought we even had was, well, the answers that we're going to get are going to be complete gibberish, or people maybe aren't even going to respond to the actual text of the question. Like, how do we know this is even going to do anything? So one of the first things we did when we got back the data was, so let me tell you also quickly about the groups of known size that we use, because this is going to be important. So we have 12 different names. These are names that are relatively common in Rwanda, and we know the number of people who have these names from the National ID database. And then these are groups defined by occupation or demographic status. And these are known through government records or through other large-scale surveys. So here, for all of those groups, the x-axis is the mean number of reported connections to people in this group using the basic definition. And here's the mean number of ties reported using the meal definition. So what we see is in all cases, for all the groups, under the meal definition, people give smaller answers. So like they were actually listening to the question and they gave answers in ways that we would expect. That was pretty cool. And you see that this is kind of approximately consistent, which suggests the shrinking is pretty much the same for each group. So next, what we can do, and this is sort of really what allows us to actually try to make some progress, is that we can pretend we don't know the size of a group and then try to estimate it using all the information from all the other groups. So here on the x-axis is the true size, and this, of course, only works for the groups where we know the true size. And then here's the estimated size in the setting where we pretend we don't know it and try to use the other groups. So obviously this would work perfect if all of these lie on the 45-degree line. And to a first approximation, the estimates are not terrible, which is nice. And these are the values for the basic definition and these for the meal definition. So this is, for example, women who have given birth in the last 12 months. This is the true value is close to 0.25. When we try to estimate it, it's about 0.02. So then the question is, if we wanted to decide which definition seems to be working better, the basic definition or the meal definition, yep?
So there seems to be a systematic overestimation and small problems.
Yes. So this is one thing that's been observed in a number of these studies, which is that people, this is not just in Rwanda, but also in data from the US and data from Brazil, people seem to give higher answers, seem to over-report knowing people in smaller groups and under-report knowing people in bigger groups. We don't know the exact origin of this response pattern. We think it might be that people subtly change the definition of what it means to be connected to someone. So if I say, how many people do you know named Ulysses? You might search deep in your memory for someone who you went to high school with named Ulysses, and you might report that. But if I said, how many people do you know named Michael? You're less likely to reach as far back in your net. But that's pure speculation. We have no idea. But that pattern has been observed in other data sets as well. So you might imagine you could try to systematically correct for that, but then obviously, so you could sort of just empirically correct for that, but you like to sort of understand why it is before you start doing some stuff to it. So then we said, okay, so which of these seems to be working better? So we want to summarize basically how far off these estimates are from the true values. So there are many ways to do that. So we could use root mean squared error, mean absolute error, average relative error. Under many different error metrics, the meal definition works better than the standard definition. So then here are the estimates for the, so here we've said, here's a question of, okay, how do we decide this tie definition? Now, in a lot of other work in this area, it would be like, well, I think it should be this, and I think it should be this, and I think it should be this, and then it would just be like never ending. So like here, we have a clear pre-specified criteria for deciding. And by several different error metrics, one works better than the other. So like we've actually potentially made some progress.
But so this plot is telling us that the red data on the previous slide should look better to us than the blue?
That's what it's telling us. I mean, it's not a huge difference. I'm going to show you also in a second. So there's two parts of this study. I think one is the actual result, and then two is the recipe, which I'll talk about a little bit at the end. So here are the 4 target populations. here are the estimates using the basic definition and the meal definition. So first you'll see that basically they're quite similar, which is actually, I think, quite good. I was pleasantly surprised that we're able to get quite different answers, but yet the amount that the numerator shrinks and the amount the denominator shrinks, we end up with quite similar estimates in the end. Also, we could talk a little bit more about the face validity of these estimates. Estimates that they're almost zero injecting drug users in Rwanda. This is very consistent with the expectations of people there. Basically, heroin is not produced locally, so it has to be imported. And so it either is flown in or comes in overland through Tanzania, which is also very expensive. There aren't a huge number of people in Rwanda with lots of disposable income, so there just aren't a lot of drug injectors there. This is so in some sense, this was something they thought there would be close to zero, and we estimate there was close to zero. So that's good. Men who have sex with men, this is very complicated and confusing. It's very clear that there are very few openly gay people in Rwanda. As far as how many people who identify as heterosexual actually have sex with other men, I don't know, and I don't think anyone really knows. And then these estimates are also roughly consistent with their expectations, although we estimate similar numbers of sex workers and clients of sex workers, which is something that they were surprised. They thought there would be many more clients than actual sex workers. But again, you could imagine situations where how this makes sense. Okay, so then they saw this and they said, great, so what should we tell the minister? I'm like, okay, well, we think the meal definitions work better based on these criteria. So let's tell the minister this. They said, but what about the rest of the data? This is 2,500 interviews. Those are very expensive. That took months of hard work traveling around the country. So he said, that's right. We should not actually throw away this other half of the data. So then we do some kind of blending. So you could imagine that your estimate for the size of the target population would be some kind of weighted average between the two definitions. And then here we define the weight to be basically about the relative mean squared errors. And so in this case, it's about 2/3. So you can think of our blended estimate as sort of 2/3 meal, 1/3 basic. And that produces these estimates here, which are in the middle. Okay, so then this gives us a sort of general recipe that we can use. So we take our sample, we split it into two arms.
Why are you splitting it into two rather than three? Because if you had three, you'd know if you're nearing that sweet spot or if you're still...
Yeah. So ideally, we'd like to do, now we would like to do three. This first time, we actually had a lot of trouble convincing them even to do two. Because all of these surveys were done on paper, and the actual, it was non-trivial to actually implement a clean survey experiment in a paper-based world. So given these results, and also we don't yet know exactly, at the time we were trying to convince them, we had no real examples of this doing something, so it's much harder. So we settled for two. So we've done these two, then we get estimates from each arm, then we blend the estimates here. So then each study produces two things. One is the blended estimate. That's what actually the minister wants. That's what the minister pays for. And then as a second sort of byproduct, we get a comparison between these two. So that allows us to say, well, in this case, the meal definition seemed to work slightly better than the basic definition. So then every study can produce these two things. One, the thing that the people who are funding the study care about. And then two is this little extra bit. And so at this point, there have been like 450 studies around the world using respondent-driven sampling. This is the other method that I worked on. And there have been very little accumulation of knowledge from all of those studies. It's just kind of, there's a lot of estimates and then little accumulation. So here, if we imagine doing 100 scale-up studies, and if every study has one of these experiments in it, then after we've done 100 of them, we'll actually learn a lot. So then we can talk a little bit about the trade-offs involved in this. So this is not completely free. So one great thing is it requires no additional information from the respondents. It doesn't require you to increase your sample size. It doesn't require you to ask additional questions to the respondents, because that stuff is automatically collected with the Scallop method. It's slightly more difficult logistically because you have to operationalize this field experiment. And then it makes the analysis slightly more complicated. However, Dennis is working on an R package, which will make the analysis much easier. So we're hoping that we'll basically decrease the added cost of doing this such that this will become a standard thing in every study. So to sort of wrap up, the question that I started with was how can we improve if we don't know how we're doing? And so in this case, we can see that we can have a sort of general recipe, which we can use within the Scallop method to try to gradually accumulate evidence over time to make sure we're getting better and better. And I hope we can figure out how to do that with the other problems in this area as well. Thank you. Yep.
I was sitting here thinking, how would you refine the estimates of casualties in the Philippines in the typhoon? Because you have the problem that the people you can ask questions of are not necessarily connected with the population that you want to know about.
Yeah, it's a huge problem. So one thing, someone asked me after the earthquake in Haiti, like, could we go do this in Haiti right now? And it's like, I think the amount that people want these estimates is like related to how difficult it is to make these estimates in some sense. So like, we can't really go into the Philippines now and take a standard probability sample. It's just that infrastructure, a lot of that infrastructure has been wrecked. So we could go and do something. But like you said, if the initial sample is somehow non-representative, so if we're somehow missing people from certain regions, then you can imagine the kinds of estimates that we'll get from this would not be totally right. Now, there may be ways of sort of modifying this, and one of the things that Dennis is working on in his dissertation is generalizing this sort of much more to accommodate lots of different methods where you have people reporting about other people, and then that can introduce a variety of problems like this problem here that some people get reported about more times than other people. But so there may be, I don't think this exact thing will work, but I think the idea of asking people about the people that they know is a possibility. Yeah.
So, I mean, you, I'm sure you didn't intend this, but you sort of implicitly suggested, this idea that you have a single parameter which you can tune to kind of make neighborhoods bigger or smaller, the graph definition more or less dense. But of course, I mean, just things like, have you had a meal with somebody versus this other definition, this is complete apples and oranges, right? And it could be that if you said a meal, you said a drink, you get completely different types of responses and recall from people, right? So, what about doing what you're suggesting, but kind of standardizing some definition which really does have a tunable parameter? I mean, it could be something like, just the number of years you ask them to think, that they had a meal, and just make it a little bit more systematic.
So here you could imagine, so basically we decided to tune basically what it means to have contact. You're saying you could also tune what time period was used. That would be much more systematic.
Well, I'm not preferring one over the other. I'm just not preferring sort of completely incomparable definitions of recall.
I would say these are not incomparable in the sense that they're nested within each other.
Yeah.
So that was the one, that was our first criteria.
Yeah, so I guess the question is, does it make sense empirically to think about not just sort of 2 points on that, but a continuum, and actually suggesting that if people are going to use this methodology 100 times going forward, that they stick within that spectrum? No,
I totally agree. So like the thing that it's not even clear that there is this just one dimension here.
Yeah.
So this is how we chose to operationalize this idea this time. I think it would be great if we could have a more general definition that would allow for, I see, so what you're saying is if we do 100 studies, we'd rather them all be connected within some overarching framework rather than be 100 sort of bits and pieces. That's definitely true. I will say one thing about the challenge of this, and the challenge of this method overall, is that it requires you to use concepts that are meaningful in that society. So initially when we went there, we said, okay, we're going to talk about sharing meals, contact and sharing meals. And our collaborators said, no, actually, very few people in Rwanda go out to eat together or have people over to eat. It's just not very common there. But sharing drinks is much more common. So we added this drink thing is totally an add-on. And so you can really only use sort of kind of social constructions that exist within that society.
Yeah, this is the problem with people.
Yes. Absolutely.
Okay, so we
Yep.
thank Matt and so we have about half an hour for a discussion. I guess the plan is to turn the cameras off. And I guess they're going to bring some chairs up. Is that right, Carolyn? And we're